Hi everyone there. Welcome back to my channel. Myself Archana M of Sri Venkateshwara College of Engineering, pursuing my graduation in 6th sem of EC domain. So today let's discuss about few problems on signaling over AWGN channel. So let's look after prerequisites to solve some problems. The first condition or the first formula is phi1 of t is equals to s1 of t divided by root of e1 of t, where e1 of t is nothing but it is an energy signal, where it is defined as it is the integration from limits 0 to t s1 square of t dt is equals to s11 for I is equals to 1. And the second formula is consider intermediate function gi of t, where gi of t is defined as si of t minus summation of j is equals to 1 to I minus 1 sij phi j of t, where j will be defined as 1, 2, 3 and so on to 1 minus I, and where Si of j is also defined as it is the integration of limits 0 to t Si of t phi j of t into dt, where j equals 1, 2, 3 so on up to n, and also phi I of t is also defined as gi of t whole divided by root of integration from 0 to t gi square of t into dt, and the third formula is root ei, which is defined as integration of 0 to t gi square of t into dt, where we can get the values of s22, s33, s44 and so on. So let's look after problem number 1. Using Gram-Schmidt organization procedure, determine orthonormal basis function for the following signals. So the signals are given as follows. Signals are S1 of t, S2 of t, S3 of t and S4 of t, and their respective waveforms are given as follows. Let's see how do we solve the previous problem. So the solution is, let's do the step 1. We already know that Si of t equals summation of j equals to 1 to n Sij phi j of t, and the conditions are given as follows, and let us consider this as equation number 1. Therefore, where Sij equals integration of 0 to t Si of t into phi j of t into dt, where I equals 1, 2, 3 and so on up to m, and also j equals 1, 2, 3 and so on up to n, and also integration from 0 to t phi j of t into phi I of t equals 1 when I equals j and 0 when I is not equal to j. And this we already studied in Gram-Schmidt orthogonalization. And let us substitute I equals 1 in equation 1. Therefore, S1 of t equals S11 phi 1 of t, where phi 1 of t can be written as S1 of t divided by S11. So let us solve for S11. Therefore, we already know that Sij equals integration from 0 to t Si of t into phi j of t into dt. Therefore, let us solve for S11. S11 equals root of integration from 0 to t S1 square of t into dt. Why? Because as we already defined in the above solution or above formula as phi j of t into phi I of t equals 1 when I equals to j, as here I and j are both are equal to 1, therefore it will be like S1 square. Therefore the root of integration 0 to t by 3 1 square into dt. How we got the limits from 0 to t3, as we already given in the question, as s1 of t is defined 1 when it is limits are from 0 to t by 3, so it can be considered as 1. So that is nothing but s1 of t can be considered as 1 with the limits 0 to t by 3. Therefore, S11 is whole defined as root of t by 3. So let us substitute S11 in the phi 1 of t. That is, phi1 of t equals s1 of t whole divided by root of t by 3. As we already defined the s1 of t, sorry, s11 of t is s11 equals root t by 3. So by solving the above equation as so the roots will be altered, like the denominator will be going to the numerator, therefore it will be equated as, so root of 3 by t s1 of t. So the overall phi1 of t can be written as, it is root of 3 by t when the t ranges from 0 to t by 3 and 0 otherwise. Like here the s1 of t is already defined as 1 when the limits are 0 to t by 3. Therefore it is understood that s1 of t is equals to 1 with the limits 0 to t by 3. And the step 2 is, let us substitute I equals 2 in equation 1 in the previous slide. That is, it will be written as S2 of t is equals to S21 into phi1 of t plus S22 into phi2 of t. So now we should find out S21, S22 and also phi1 of t and phi2 of t, as here the values of I and j will be different. So let us solve for S21. That is equal to integration from 0 to t s2 of t into phi1 of t into dt. And the waveforms for s2 of t is given in already in the question, therefore the waveforms is given as follows. And phi1 of t, which we already solved in the previous slide, that is phi1 of t, it is it is a root of 3 by t when it ranges from 0 to t by 3. So the waveforms is been drawn. Let us substitute the values here. So s21 equals, it is integration from 0 to t by 3. So the s2 of t is 1 when it is ranges from 0 to t, sorry, 2 into t by 3. Therefore s21 equals integration from 0 to t by 3. It is 1 into the phi1 of t value is nothing but root of 3 by t into dt. So the values will be changing here, sorry, the limits will be changing here, and the final value will be is nothing but s21 will be equal to root of t by 3 by solving the above equation. And let us find out s22. That is nothing but it is the integration of t by 3 to 2t by 3 g2 square of t into dt whole bracket power 1 by 2. 1 by 2 is nothing but it is the root. So by solving the above equation, we will get s22 as root t by 3. How we got, let us see here. So g2 of t is nothing but s22 into phi2 of t. So s22 is nothing but it is the integration from 0 to t g2 square of t into dt whole power 1 by 2. So let us solve for g2 of t. That is nothing but g2 of t is equals to s2 of t minus s21 phi1 of t, where the phi2 of t can be written as g2 of t whole divided by s22. So that is understood. And the waveforms is given as follows for s2 of t, s21 into phi1 of t, and also for g2 of t. And the overall values for all these problems is like the phi2 of t can be having the value as g2 of t whole divided by root of t by 3. That the denominator will be going to the numerator, so it will be equated as root 3 by t into g2 of t with the conditions as, so g2 of t will be equal to 1 with the respective limits. Therefore the final value for phi2 of t will be given as, it is root 3 by t when the t ranges from t by 3 to 2 into t by 3, and it is 0 when 0 to 2, sorry, 0 to t by 3, as the waveforms as shown here. Now let's do step 3. So first we should substitute I value as 3 in equation 1. Therefore s3 of t equals s31 into phi1 of t plus s32 into phi2 of t plus s33 into phi3 of t, where now we should find out S31, S32 and S33, and also phi1, phi2, phi3 also. So let us solve for S31, which is equals to, integration from 0 to t s3 of t into phi1 of t into dt, and also s32 equals integration from 0 to t s3 of t into phi2 of t into dt. So the value which can be find out for S33 is given as we know that G3 of t equals S33 into phi 3 of t. Therefore, S33 is nothing but root of integration from 0 to t G3 square of t into dt. Therefore, phi 3 of t's value can be found out as G3 of t whole divided by S33, and the value for S31 will be equal to 0. Why? Because as we already studied the waveform of S3 of t in the given question, as it is 1 when the t value ranges from t by 3 to t, and the phi1 here it should be multiplied with phi1 of t. Therefore, the phi1 of t is already defined in the step 1 procedure as it is root 3 by t when the t value ranges from 0 to t by 3. So when we multiply both of these waveforms, we will be resulting with the value 0. Why? Because here the value from 0 to t by 3 is 0, and here the value from 0 to t by 3 is some root 3 by t, and from t by 3 to t it is 1. Here from t by 3 to t it is nothing but 0. So when we multiply 0 into 0, we will be resulting with the value 0. Therefore, S31 will be equal to 0. Now we should find out S32. So it is the integration from 0 to t S3 of t into phi 2 of t into dt. So first we should be knowing the value of phi 2 of t and S3 of t. Therefore, let us substitute, as we know that S3 of t value will be equal to 1 when it is ranges from t by 3 to t. So we had already substituted here as 1, and the value for what is that phi 2 of t is nothing but root 3 of t whole divided root 3 by t, which we already solved in step 2. So with the therefore it is already defined as S32 equals integration from t by 3 to 2 into t by 3 into 1 into root 3 by t into dt, and the respective waveforms is given as here as the value is given here. So S3 of t as already given in the question, the same waveform has been written here, and also the phi 2 value is nothing but we already find out in the previous slide, that is in the step 2, as it is root 3 by t when the t ranges from t by 3 to 2 t by 3. So the value of phi 2 is nothing but root 3 by t with the value ranges from t by 3 to 2 into t by 3. So that is what we had already substituted here. Here we had took the values from when we just multiplied here, we can range the value from t by 3 to t by 3, which is the waveform is present here, and at mid of this waveform, that is 2 into t by 3. Here the value, like here the waveform has been which is going from root 3 by t to 0. So we can take, when we multiplied this, we will get the values only from here to here, that is nothing but 2 by 3 to 2 into t by 3, and this value will be nothing but 2 into t by 3 is to t will be equal to 0. So the waveform which is only present only from t by 3 to 2 into t by 3 with the value 1 into root 3 by t. So that is the thing which has been written here, and when we solve by applying these limits, we will be resulting with the value S32 equal to root of t by 3 and G3 of t. So we should find out S3 of S33. So G3 of t is equals to S3 of t minus S31 phi 1 of t minus S32 phi 2 of t. As we already know the value of S3 of t, which is been already given in the question, and the same value like S31 into phi 1 of t, which is already been given, like we already solved here. So the when we multiplied here, what will be the resulted waveform, that is been written here. So the value will be like a 0, like S31 into phi 1 of t will be value will be 0, and similarly I have already told that it will the waveform only will be appearing here is the resulting waveform will be ranges from t by 3 to 2 t by 3, only in that timing, that or only in that interval the waveform will be raised to root 3 1 by t. like root 3 by t. So the resulting waveform is been written here, and the value is also been written here, like s3 2 into phi 2 of t is nothing but it will be equal to 1. So when we substitute these values in this above equation, we will be resulting with the values like g3 of t equals, it is ranges from 0 to t by 3. The whole over value will be like 0, from 0 to t by 3. So from 0 to t by 3, the all values will be equal to, see here, so the all the values are 0 when we substitute in this above equation. And the same g3 of t when the t ranges from t by 3 to t. So from t by 3 to t, here in the s3 waveform it will be 1, and when s3 1 into phi 1 of t, it will be equal to 0. So 0 has been substituted here, minus s3 2 into phi 2 of t. So here, so t by 3 to t, it is nothing but it is like mid, it is 1 from up to 2 t by 3 is t3 t by 2. So t by 3 to 2 t by 3 is nothing but here it is 1, here it is 0, and here it is also 1. So 1 0 1. So when we just multiply here, the plus and minus will be just a plus 1 and minus will be cancelled, the resulting value will be 0. And similarly g3 of t when the t ranges from 2 into t by 3 to t, like here only here is which has been present here, 2t by 3 to t, it is 1. So it is 1, and the second is nothing but 0, we already written as 0. And from here 2t by 3 to t, it is nothing but 0, so the final value will be 1. Therefore the g3 of t equals, it is defined as it is 1 when the value ranges from 2t by 3 to t. See, the same has been written, and it is 0 otherwise, or it also can be written as it is it is 0 when the t ranges from 0 to t by 3 when t is greater than capital letter T. And the final step is given as follows, as therefore S33 is nothing but it is the root of integration from 2 into t by 3 to t and g3 square of t into dt. So when we substitute the respective value of g3 of t here, like it will be resulting with root 3 into capital letter T to t by 3. So the value will be root of t by 3. Therefore the s3 value will be is nothing but a root of t by 3. When we already know that the phi 3 of t can be written as s3 of t whole divided by s33. When we substitute the same value here, like the phi 3 of t will be defined as it is nothing but root of 3 by t into s3 of t. That is nothing but s3 of t is equal to 1 with the given like a given waveform in the given question. So the s3 of t value will be equal to 1 with the respective limits. Therefore phi 3 of t is defined as it is root 3 by t when the t ranges from t by 3 to t and 0 otherwise. And the step 4 is nothing but from waveform given. So as we know that s1 of t is given as so and so, s3 of t so and so, and s4 of t can be written as s1 of t plus s3 of t. We will be resulting with the value s4 of t. So the value will be ranging as it is 1 when the t value ranges from 0 to t. So therefore the s1 of t is given as it is nothing but root of t by 3 into phi 1 of t. s2 of t is nothing but root of t by 3 into phi 1 of t plus root of t by 3 into phi 2 of t. And s3 of t is nothing but root of t by 3 into phi 2 of t. And finally s4 of t is nothing but root of t by 3 into phi 1 of t plus root of 3t by 3 into phi 2 of t. And the respective values of phi 1 phi 2 should be substituted here. And as we already substituted, and already we got the values of phi 1 and phi 2 of t in the previous slides. So we will be ending this problem with the result here. Thank you everyone.